Okay, hi, good day everyone. So today what we're going to do is continue our studies of quadratic functions. Today we're going to start solving quadratic equations, okay? And we're going to solve those by graphing. So your essential question for today is how can you use the graph of a quadratic equation to determine the number of real solutions of that equation? Okay, so basically in short, what will you learn is how to solve quadratic equations by graphing. So we're going to start with what we already know. So when solving a quadratic equation by graphing, first things first, a quadratic equation in one variable is an equation that can be written in standard form. F of x equals ax squared plus bx plus c, or you may see it as y equals ax squared plus bx plus c, where a cannot equal 0. If a equals 0, we will completely take away the x squared property, leaving us with a linear equation. That's why a cannot equal 0. A, b, and c in that equation will all be real numbers. Now, a root of an equation, and some of these words, they're going to start popping up. So you're going to have to know them. They are used interchangeably with solving a quadratic equation. Okay, so a root of an equation is a solution of the equation. We're going to start by finding the x-intercepts of the related function. So there are 4 words that will represent what the x-intercepts are in a quadratic equation. You will hear them interchangeably. They are the root of an equation, the solution to an equation, the x-intercepts, and the last word is going to be zeros. That will be introduced a little bit later, but zeros, roots, solutions, and x-intercepts all refer to the same thing, the x-intercept. Okay, so here's where we're going to start. Solve each equation by graphing. X squared minus x minus 6 equals 0. Well, here's some things that I need you to know. When an equation equals 0, we can also say that that equation is y equals x squared minus x minus 6. Okay, now, before in previous lessons, we talked about how you can find the vertex. A vertex is a key component when we're graphing because that lets you know what your maximum or what your minimum value is. Okay, in this case, let's see here. Our vertex equation, we have an equation in standard form, so it's the opposite of b over 2a times, and we'll plug in whatever we get there in for the y value. Okay, so what I'm going to do right now is stop this for a second, and I'm going to plug in a and b into the equation and set that up for you. So I took some time and I set some things up to find what the vertex is. I wrote my equation in standard form and matched it up. A is 1, B is -1, and C is a -6. So what I'm going to do now is substitute in those values into what I know the H value or the X term would be in our standard form equation for our vertex. So this is going to give me the opposite of a -1 divided by 2 times A. Okay, so you should know what your vertex is. I'm going to pause it so that you can type it in. Your vertex is 1/2. That's the X value. Okay, now to find the Y value, we would plug in 1/2 into the given equation. That's what that F of that stands for. We will plug in this 1/2 into the equation into every single spot. So I'm going to pause it so that you can set that up. I'm going to do some math here, but it's going to go by pretty quickly. Okay, we already know what the H value is inside of our vertex is 1/2. To figure out what the K value would be, I plugged in to the equation 1/2 for both of the X's and left the 6 alone. So here's what I know. If I was to square 1/2, that's going to give me 1/2 times 1/2. That's 1/4. So since I know the denominator here needs to be a 4, I'm going to go ahead on and change everything else to a denominator of 4. Now, if this is tricky for you, then I need you to say something. But this equation, top line, this first line, is equivalent to this second line. Okay, so now we have 1 minus 2, which is going to be a -1. minus 24 is going to give you a k value, or y in this case is going to be a negative 25 over 4, which is about a negative 6 and 1/4, or if you want to make it a decimal, a negative 6.25. Okay, so in doing that, we know that if we were to do our table of values, then one of our key points is going to be at a half and a negative 6.25. That point is special because that point tells us our vertex. Okay, now we can do some more math to figure out where the other points would lie. One of the things that I like to look at when graphing a quadratic is to determine where the y-intercept is. And the y-intercept always happens when the x value is 0. Okay, so I'm going to set that up. Oh, so here we go. We're at the y-intercept. The y-intercept is when x is equal to 0. So I took the original equation and substituted in zeros. The y-intercept happens when x is 0. Y is going to be a negative 6. So that gave me 2 points already. Okay, now let's talk about those x-intercepts, because we do need to know where those are. Okay, so let me plot the points that we have so far. Then I wanted to put some more things on our graph, so I went ahead and labeled our axes of symmetry, the line when x is equal to a half, and because I had a point at 0, negative 6, that was a half away from the axis of symmetry, I know I would have another point at 1, negative 6. So now I want to look at some other points on the graph. So I'm going to choose some more points to determine where my graph is going. I want you to take some time, look at the point positive 2, and see where that graph is going to be. In terms of y, what will y be when x is a positive 2? Folks, so I use my axis of symmetry to determine if there's a point at 2, negative 4, then there must also be a point at negative 1 and a negative 4 as well. So now I want to see what happens when x is 3. So you try out what will y equal when x is equal to a positive 3. Let's give it a go. So folks, to determine what the y variable was, I substituted in that 3, and I have a point at 3, 0. This point is very, very important because this point here represents our x-intercept, which is our root. It is our solution. It is also our 0 to our function, okay? So we have one x-intercept at 3, 0 when x is a positive 3. Now I'm going to use my axis of symmetry to determine what that other point should be. So if I am 1, 2.5 away from the axis of symmetry, then I'll be a half and 2 more away. So I'll have another x-intercept when x is equal to a negative 2 and a positive 0. I shouldn't have did that like that, but that's okay. All right, now these 2 points here, 3, 0 and negative 2, 0, these represent your solution to your quadratic function. Now, I'm going to fill in my graph. Folks, this is my graph for my equation x squared minus x minus 6 equals y. And my most important things I'm going to point out is going to be my x-intercept. This is my x-intercept. I have 1 on both sides. And we might as well do some more vocabulary. This bottom point here represents our vertex. Since our graph opens upward, this represents our minimum value. Our minimum here would be a negative 6, I believe. Yep. That is when y is equal to negative 6. That's the lowest that the graph goes. Something else that's worth pointing out is that I don't have space, but I'm going to write it anyway. Okay, we're going to put it someplace that's important. Okay, your domain of this graph, because it continues going to the left and it continues going to the right, is from a negative infinity all the way over to a positive infinity. Yes, we still do domain and range. The range in this case would be this graph goes as low as a -6, and we include that -6, and it goes as high up as positive infinity. Okay, so just some things to point out as we work through this. Now, if you don't understand something that I said, please pause the video, take a picture of it, screenshot or whatnot, and ask your teacher. Okay, that's why we're here. We're here for you to ask us questions when you don't understand something. Okay, now let's move on into example 1b. Example 1b, you're going to solve each equation by graphing. We're given a -2x² minus 2 equals 4x. So the first thing that I want to do is make sure that this is in standard form. This is not considered standard form because 4x is on the side when it needs to be on the side with all the other terms. Okay, this needs to equal 0, or it needs to equal y, or it needs to equal f of x, or something along those lines. So let's fix this. Okay, that's the first step. -2x² minus 2 equals 4x. Because you want this term or this side to equal 0, the only thing that you can do to get rid of that 4x is to subtract 4x on both sides. Okay, when you subtract 4x, make sure that you keep things in standard form order. So you want to start out with your square term first, -2x². Your linear term is next, and then your constant, and that equals 0. Okay, so now the next thing that I want you to do is figure out what the vertex is, and I'm going to try to be a little bit more organized with this one. Okay, sneak peek for you in case you're struggling with identifying what that vertex should be. Alrighty, now you're on your own with identifying the vertex. So that's what I came up with. H is a -1, K is going to be 0. I went ahead and plotted my vertex on the graph as well as labeled some key features for it. Okay, folks, not much change. I just labeled the axis of symmetry, and now I'm going to start with the y-intercept. I want to know where it intersects the y-axis. Let's go. You try it on your own. We're using that same equation that we found right in here. So all you're going to do is substitute in zeros for x, and that's going to tell you where the y-intercept is. So here's some things that I found. When x is equal to 0, y equals a -2. So I would have a point at 0, -2, but then when using the axis of symmetry, if 0, -2 is 1 unit away from the axis of symmetry, then my other point, I'm going to have another point at -2, because that is equidistant from the axis of symmetry. Now, if you wanted to go ahead and find more points, you can. I would encourage you to make sure that you have your 2. This one, of course, if you look at the -2 in the front, we know that it was going to open downward. We know that it's going to be a slight vertical stretch by 2. And so I'm okay with you kind of filling it in, you know, as you need. Of course, my line is going to be terrible because I'm a terrible drawer. But here we go. What's most important here is that we have a point that's doing a lot of double duty here. Okay, so our vertex is at -1, 0. But this vertex also happens to represent something else that's very important. This vertex is actually double duty. It is your x-intercept. It is your 0 of your function. It is the solution. It is also considered the root. So remember I said that those 4 words will be used interchangeably, but your vertex in this case is actually your solution. It touches the graph in one point. It did as we expected. It opened downward, and it did do like a little stretch. Okay, so that's going to wrap up what I have for you so far. I'm going to put in some questions for you, which is going to look like the same thing, but I need you to be able to identify your vertex as well as your y-intercept, and if necessary, your x-intercept. Okay, see there, our y-intercept had double duty. Our x-intercept, not the y-intercept, oh my gravy, it's the x-intercept. Oops, I should not have done that, excuse me. but your vertex ended up being the x-intercept and everything else. Okay, so you all, oh, I forgot, I can say a little bit more because of the thingy here. So I'm going to put in two graphs here. The first one that you're going to try first, it asks you to solve it by graphing it, which is what we just did. So I'm going to leave that there for a moment so you can look at it. So that's that. And then the next one that you're going to try is here, is example 1D. Now, because we're using Edpuzzle, you'll have to be a little bit creative. You're going to need your own paper and pencil to get yourself started. But this is what we're doing today, folks. So if you have any questions on how to do C or D, or you see that you didn't get your answers right, then I need you to say something. You can say something to your teacher. You can say something to myself. If you choose to be shy, baby, closed mouths don't get fed. You hear? I'm sorry, I had to drop my accent. But yeah, you need to say something. You can't be shy. I'm hoping that you notice with this online learning, we don't know what you thinking. We can't see your confusion. Okay, you need to open up your mouth and say something, okay? And that's coming from a place of love, okay? I want you to do good. I want you to be good and treat others how you want to be treated, okay? Thank you all for watching. Have a nice day.